Chapter 2, Review of Basic Mathematical Skills. We'll skip over the keywords. We'll cover them in the chapter. Wait a bit. So this is the only chapter that I would expect anybody to maybe be able to do the pre-test. I know that for a lot of you, this kind of stuff has been something you haven't done in a very long time. So if you are feeling a little overwhelmed, like, oh my God, I don't remember any of this stuff, don't be, because you're not the only one in this position. If you're not feeling comfortable with this stuff, this is a good chapter to do the pre-test and go through some of the practice problems. And this is the chapter that will kind of give you the foundation for doing the more complex calculations we'll be doing. So I'm going to skip over the pre-test, but again, if you are feeling good, you can go ahead and test yourself. So in calculations of medications, accuracy is extremely important for patient safety. The patient depends on your calculations, and the pharmacist expects you to correctly make those calculations. Answers must be precise. Partially correct answers are unacceptable and may endanger patient safety. Basic math skills are essential in pharmacy. Always look at your answer and ask, does this make sense? Use estimation and your knowledge of normal medication doses to be sure your answer is within a normal range. All right, whole numbers. A whole number is a numeral consisting of one or more digits that is not followed by decimal or fractions. The digits used in math are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Numbers may also be written in words such as 1, 2, 10, 100, 130, and so on. Commas are recommended to be used on medication doses greater than 999, according to the ISMP. So therefore, if you have a dose of 1,000 units of heparin, it should be written as 1,000 units. A whole number is always to be the left of a decimal point. The numeral 0 is a whole number with the decimal understood to be at the right side of the 0. When adding, subtracting, or multiplying whole numbers, the answer will always be a whole number. This is not always the case when dividing whole numbers. Any number that remains when numbers are not exactly divisible is called a remainder and is expressed as a fraction or decimal. When adding or subtracting whole numbers, align the digits from the right and then add or subtract one set of digits at a time, starting from right. Addition is finding a sum or totals of numbers. Subtraction is finding the difference between two numbers. So we'll go ahead and do example 2.1. All right, so the first example 2.1, you'll see I have my calculator out. So these are just 4 different addition and subtraction problems. So if you're not feeling comfortable even with addition or subtraction, don't be embarrassed or don't feel any type of way, because you will be feeling just fine by the end of your time in the program, and you'll be comfortable, I promise you. But you do get to use a calculator in this class, and you do get to use a calculator on the PTCB, and more than likely you're going to have calculators everywhere in the pharmacy or on your computer in the pharmacy. So you're really never going to be expected to figure out things quickly in your head. You're going to be able to have to figure them out quickly on a calculator. So simply for all of these, you can just do addition and subtraction, and here are all the answers, so we won't go through those. When multiplying whole numbers, align the numbers or factors as you would for addition or subtraction. The use of X, or this little dot here, denotes that the number should be multiplied to find a product. Remember that a number multiplied by 0 is 0. First, multiply the number on top of the problem by the number at the far right of the bottom of the equation. Place the ones digit of the answer under the line and carry the tens digit to the next place. Multiply the remaining numbers in the subsequent digits, moving from right to left, keeping the numbers in alignment. Move to the next number to the left in the bottom number and repeat the process. Remember that the second answer is already in the tens place, so it must be placed one space to the left of the first answer. So let's do example 2.2. Example 2.2, we have multiplication problems. So again, you can use your calculator on these to figure this out. Same with example 2.3, but this does kind of show the alignment. If you had to figure them out by hand when you have the 0 here and the 2 digits. Division is represented by either the symbol or the symbol. The number being divided is called the dividend, and the number used to divide is the divisor. The result of division is the quotient. All right, let's do example 2.4. Example 2.4 is a division problem. So again, you can use your calculator for this. When a whole number or unit is divided into parts, the parts are called fractions. Fractions may be expressed in the form of A/B or A over B, with the latter being preferred with the pharmaceutical calculations for ease of keeping track of units and reducing numbers. The A in that example is the numerator, the top number found in the fraction, and the B is the denominator, the bottom number of the fraction. Both numbers must be whole numbers, and the denominator can never be 0, which is undefined. The denominator tells how many times the whole unit has been divided. The circle graph pictured shows a proper fraction. The shaded area shows the parts of a whole. There are 3 numerator parts out of 4 denominators shaded, or 3/4. So fractions are used in pharmacy in both the household and apothecary systems, but not with the metric system. A proper fraction is one in which the numerator is less than the denominator and is part of a whole, such as 2/3 or 5/8. Its value is always less than 1. An improper fraction is a fraction in which the numerator is greater than or equal to the denominator, making the fraction equivalent to or greater than 1, such as 9/8 or 1 1/8. And 14/7, which equals 2. If the numerator and denominator are the same, the value is 1, such as 9/9 and 10/10. An improper fraction can be changed into a mixed number, a whole number, and a fraction. Because a fraction indicates division, the numerator divided by the denominator when A over B or A over B is written. The fraction actually means A divided by B. To convert or change an improper fraction to a mixed number, divide the numerator by the denominator. Any remainder is written over the denominator. So let's do example 2.5. All right, so in example 2.5, convert the improper fraction 43/8 to a mixed number. So this is the one part where we will have to know long division. So we're just going to go 8 into 43. Eight goes into 43 evenly 5 times. So 40, and then we have 3 left. And then we carry, so our 3 is here, and we carry that 8 over here. And our answer is 5 3/8. Example 2.6, convert 4 1/8 to an improper fraction. So what we're going to do for this one is we're going to take the denominator and multiply that by the whole number. So 8 times 4 is 32. Then we're going to add this top number. So 33. And we keep the denominator the same. So 33/8. Some fractions called equivalent fractions have the same value. The fraction 1/2 is equivalent to 2/4, 3/6, or 50/100 with 2/4. The numerator and denominator can both be divided by 2 to give 1/2. With 3/6, both parts can be divided by 3 to give 1/2. and so on and so forth. When reducing fractions, the numerator and the denominator must be divided by the same non-zero number. For example, 3/12 can be reduced to 1/4 by dividing the numerator and denominator by 3. A fraction is reduced to the lowest term when no common number will divide into both the denominator and the numerator evenly. When adding or subtracting fractions, the denominators must be the same. Once the denominators are the same number, the numerators may be either added or subtracted. The denominator remains the same. All right, let's do these examples. Example 2.7. So this is pretty simple, adding and subtracting in terms of fractions. So we have 3/5 plus 1/5. We have the same denominator, so we don't have to worry about anything. We just have to add the 3 and the 1, and we get 4/5. Example 2.8 is the same as the previous example. We have a subtraction problem, but they're the same denominator. So we can just rewrite them like this. And we know the 5 is going to stay the same. 3 minus 1 is 2. And that's obviously what they have as their answer. So 2/5. If the denominators are not the same, the smallest whole number that can be divided evenly by both denominators within the problem is needed. That is called the LCD, the least common denominator. Sometimes the LCD is easily found because one denominator can be divided by the other. Since 15 is divisible by 5, it is common denominator for 3/5 and 2/15. To change fractions to their equivalent fractions for adding or subtracting, first find the lowest common denominator, then multiply the numerator and the denominator of each fraction by the fraction equaling 1. That will make the denominators equal to the LCD. Then add or subtract the fractions by adding or subtracting the numerators and leaving the denominator the same. Let's do that in 2.9. Example 2.9, we have two fractions, 3/10 and 2/15. They do not have the same denominator, and we need to subtract them. So we have to find the lowest common denominator between the two. So the lowest number that they both will evenly divide into by. So looking at those, 10 and 15 can't go into 10. So I'm thinking it's going to be 30. All right, so now to do this, I'm gonna go 15 divided by 30 is 2. So 2 times 2 is 4. And then here, 10 goes into 30 3 times. And again, I'm not using my calculator, but if you need to, you totally can. And that is 9/30. So now I just need to subtract 9 minus 4, which is 5. 5 over 30. And then I need to reduce that to the lowest term. So I'm going to divide 5 into each. I think that will give me the lowest. 5 divided by 5 is 1, and 30 divided by 5 is 6. So the answer is 1/6. Example 2.10. So we have an addition problem, but we have a mixed number. So it would be nice if we didn't have to deal with a mixed number. We could just deal with the two fractions, but we can't. So we need to turn that mixed number into an improper fraction. So to do that, we're going to multiply the 8 by the 3 together, which is 24. And then we're going to add 5 to that, which gives me 29. And then we keep 8 the same. And then, so now I have 29 over 8 plus 3/4. Now I need to find the lowest common denominator between 8 and 4, which 4 goes into 8, so we'll do 8. 4 goes into 8. 8 divided by 4 is 2. 3 times 2 is 6. 8 goes into 8 once. 29 times 1 is 29. So now we would just add the 29 plus 6. We get 35 over 8. Now we don't want to leave that improper, so we need to turn it into a mixed number by going 8 divided by 35. So 8 times 5 is 40, so it can't be 5. 4. 8 times 4 is 32. 35 minus 32 is 3. That is our numerator, and we keep the 8 the same. So the answer is 4 3/8. To find the product of fractions, multiply the numerators and the denominators. The product should then be reduced to the lowest term. Multiplication of fractions does not require a common denominator. Let's do example 2.11. Example 2.11, so we have multiplication. Multiplication is really simple. All we're gonna do is so they have it written here like that. 5 times 3 is 15, which they have there, and 6 times 5 is 30. So we have 15 over 30. And we just need to bring that down to lowest terms. So let's try to divide 15 into these. So 15 divided by 15 is 1, and 30 divided by 15 is 2. So the answer is 1/2. Dividing fractions involves inverting the divisor, the second number in the expression, which is the number to the right of the division sign, so that the numerator becomes the denominator and the denominator becomes the numerator. In simple terms, the numbers switch places. So let's do this example before it gets too confusing. Example 2.12. So we have a division problem. So division is the same as multiplication, but first we need to rewrite it as 4/5 times, and then the next fraction we need to switch the numbers around, invert it. So 10 over 5. So we'll just multiply across. So 4 times 10 is 40, and 5 times 5 is 25. So if we turn this into a mixed number, 25 can only go into 40 evenly once. 40 minus 25 is 15. So then we get 1 and 15 over 25. That 15 over 25 can also be further reduced. I know it's so fun. Let's try 5. So we'll do 15 over 25. 5 divided by 15 is 3. And 5 into 25 is 5. So our answer is 1 3/5. Complex fractions are fractional expressions in which the numerator and denominator both are expressed as fractions or decimals. This will be covered again in later chapters. Solving these fractions can be approached in a couple of different ways. So we'll do that example. Example 2.13, complex fractions, 1/4 and 1/2 can be multiplied by 4 over 4 to convert it to 1/2, which then can be written as 1/4 divided by 1/2 and then inverted and multiplied. And then 0.4 over 60 can be multiplied by 10 over 10 to form the fraction 4 over 600, which reduces to 1 over 150. 0.4 over 60 can be written 4 divided by 10, 4 over 10 divided by 60 over 1, and then inverted and multiplied to get 1 over 150. Decimals are actually fractions with a denominator of 10, 100, and 1,000, or any multiple of 10. Decimal numbers may include a whole number, a decimal point, and the decimal fraction. The metric system is the most commonly used measurement system in the medical field, which uses decimals. To avoid errors in the medical field, a decimal less than 1 should always be written with a leading 0. So it shouldn't be 0.25, it should be 0.25 when you write it. And same over here. All right. To compare a decimal, the decimal amounts must be aligned at the decimal point and zeros should be added so that the numbers following the decimal point contain the same number of decimal places. This is important in the comparison of medications in the metric system of measurement. So let's do this example 2.14. Example 2.14, compare 0.125, 0.25, and 0.5. So 0.125 may appear to be the largest number, but when the numbers are aligned and the proper zeros are added for numbers to have equal decimal places to the right of the decimal point, this proves to be incorrect. So it shows you here, that's actually the smallest and 0.5 is the largest. When calculating doses of medications, decimals may need to be rounded to a specific place value. Accuracy in calculating to a particular decimal place is necessary in some circumstances, whereas rounding or approximating is acceptable in others. So we have the steps for rounding. Step 1, underline the digit to the place for rounding. Step 2, look at the digit to the right of the underlined digit. If it is greater than or equal to 5, round the underlined digit to the next highest number and drop all digits to the right. If it is less than 5, drop all digits to the right of the underlined digit and keep it the same. Let's do example 2.15. So for rounding, example 2.15, round 1 to 16 to the 10th place. The 6 indicates that the number to its left needs to be rounded up to 1.2. So this is the tens place. And then this one, 1.14. We would leave that the same or 1.1. So 5 or higher, we round up. 4 below, we keep the same. Adding and subtracting decimals requires aligning whole numbers and decimal points. After aligning the decimal points, add zeros at the end of the decimal fraction until all decimal numbers are to the same decimal place. Then just add or subtract as you would for whole numbers, remembering to correctly place the decimal point in the answer. Example 2.16. This is just subtracting with decimals. So again, you get your calculator, so you shouldn't have too hard of a time doing it, but you can see that they have the zeros aligned here, so you know exactly what you're doing. Multiplying decimals is similar to multiplying whole numbers. The alignment of the numbers is identical without regard to the placement of the decimal. The difference is the proper placement of the decimal after the product has been calculated. After the product is calculated, count the number of places to the right of the decimal points in both of the numbers that were multiplied. Finally, place a decimal point in the product by counting from right to left the number of decimal places found in both elements of the problem. For example, 2.17, you can just go ahead and use your calculator, but this kind of shows you how you would complete the problem in more depth. Dividing decimals is much like dividing whole numbers. Write the problem as for long division. If a decimal appears in the divisor, move the decimal to the right until the divisor is a whole number. Then move the decimal point in the dividend to the same number of places to the right. So let's do example 2.18. Example 2.18. I, again, will just tell you that you can use your calculator, so we don't need to go over that. Same with example 2.19, 2.20. Example 2.19, again, you're just using your calculator, so there shouldn't be an issue. Same with example 2.20. A decimal point separates the whole number that appears to the left and the decimal fraction that is found on the right. To convert a decimal to a fraction, the numerator is the number following the decimal point and the denominator is a power of 10, dependent on the number of digits following the decimal. Example 2.21, so we're taking fractions and turning them into decimals. This is really simple. It explains it here to a T, but just so we can quickly kind of go over it. So say we have the fraction 1/8. And let's say we have 2/3, and then let's say we have 2/5. So we're gonna turn these all into fractions. So 1 divided by 8. So that's all we're doing is taking the top number and dividing it by the bottom. So this gives us 0.125. 2 divided by 3 gives us 0.67. And 2 divided by 5 gives us 0.4. A percent is a part of 100 as a fraction, such as 1/100. And hundreds as a decimal. Percents are used to describe medication strengths, to determine the amount of solute in a solvent when preparing medications, to determine the amount of medication that has been administered over a given amount of time, and to determine discounts and markups in retail pharmacy. Let's do example 2.2. 2.2. Example 2.22, change 16% to a fraction. So 16% becomes 16/100. Why? Because percents are always out of 100. So essentially that's the fraction. But then we need to reduce it to lowest terms. So we have the answer 4/25. And it looks like they used 4 as the number to divide into both of them to bring it to lowest terms. Example 2.23, change to a fraction. So 2 2/5 is equal to 12/5. So we change this mixed number to improper fraction. We then place the 12/5 and divide that by 100/1. And then of course we have to invert fractions, so we have it 12/5 times 1/100. So because we have to invert those when we're doing division. So we get the answer 12/500, and then we need to bring that to lowest terms. So we have the answer of 3/125. Example 2.24, we're changing 8% to a fraction. Only thing here different is we have a decimal. So if you look at the example in the book, it kind of shows you a little bit of a confusing way to figure it out. So I'm just gonna rewrite it as 0.5/100, which is what we do to turn percentages into fractions. And obviously we can't leave it this way. But if we divide both of these numbers by 0.5 on the top, 0.5 divided by 0.5 is 1. And then 100 divided by 0.5, I've already done the calculation, is 200. So that's our answer, 1/200. The denominator in a percent is always 100 because any percent is part of 100, and the number beside the percent sign becomes the numerator. To convert a fraction to a percent, multiply the fraction by 100 or by 100 over 1, which is the same thing, and add the percent sign. This is the same as changing the fraction to a decimal and moving the decimal place to the right 2 places. So let's do example 2.25. All right, so example 2.25. We're going to convert 1/5 to a percent. So 1 divided by 5, this is how I do it. So first I take that fraction and do 1 divided by 5, and I get 0.2. And then I need to multiply that by 100 to get my percent. So this is how they set it up. I think that's a little more confusing, but whatever way is best for you. And then we get 20%. So example 2.26 is the same thing. So we have a fraction, we're turning into a percent. Only thing is we have a mixed number. So you can see here, they've already done the math. 13 over 5 is our mixed number, and then we would just multiply 13 by, or sorry, we would divide 13 divided by 5. And then we would multiply that by 100. So 2.6, and then multiply that by 100, and we get 260%. So you can see here how they did that. This is how I do it. So whatever way is best for you. And if you need a refresher on how to do this, remember 5 times 2. So you take the numerator, multiply that by the whole number. That's 10. You add the numerator. Sorry, that's the denominator. You multiply the denominator times the whole number, and then you add the numerator and you get 13. You keep the denominator the same.
Yes.
To convert a percent to a decimal, drop the percent sign and divide the number by 100. This can be accomplished by moving the decimal point 2 places to the left. Let's just go ahead and do the example so it doesn't get too confusing. Example 2.27, we're converting 1/2% to a decimal. So to convert a fraction to a decimal, we just do 1 divided by 2. We take the numerator and the denominator, which they've done here, and that is 0.5. And we add the percentage sign that had nothing to do with that. So 0.5%. To convert a decimal to a percent, multiply by 100, which results in the decimal place being moved 2 places to the right, and add a percent sign. And let's do example 2.28. Example 2.28. Express 0.5 as a percent. So these are pretty simple. So to convert a decimal to a percent, all you do is take the decimal and multiply it by 100. You can see what they have in the book there, but oops. So we get 50%. This table contains some common fractions, decimals, and percents for quick reference. It's a nice little. A ratio indicates the relationship of one number to another or one number to a whole. A ratio expresses a numerator and denominator separated by a colon rather than the division line found in fractions. So basically ratios and fractions are kind of the same thing. They're just written differently. Numerators are to the left of the colon and denominators are to the right. And we'll go ahead and do example 2.29, or it's too confusing with all those words. For example, 2.29, we need to establish a ratio of 3 inches to 1 foot. So the first thing we need to do is change the foot to inches, so 1 foot is equal to 12 inches. So then we can easily write our ratio as 3 to 12. And then we just need to simplify it, just like we would a fraction. So if I rewrite it as 3 over 12, and if I need to bring it down to lowest terms, I'll divide both numbers by 3. I think that will work. So 3 divided by 3 is 1, and 12 divided by 3 is 4. So 1/4 is the fraction, so our ratio is 1 to 4. Example 2.30, establish a ratio for 5 milligrams per 125 ml and reduce. So you can see here, they've rewritten it as 5 milligrams to 125 ml. And then we want to just bring that down to lowest terms. So let's just say let's just rewrite it as 5 over 125. If we divide both of these by 5, so 5 divided by 5 is 1, and then 125 divided by 5 is 25. We get 1 over 25, which is the same as 1 to 25. And then we would, keep that milligrams and milliliters as well in the problem. A true proportion is an expression of equality between two equivalent ratios, such as 4 to 8 and 6 to 12. Placing these in a proportional equation, 4 to 8, 8 to 6, or 6 to 12, or a fractional equation is read 4 is to 8 as 6 is to 12. In these pairs of numbers, the relationship between 4 and 8 is that 8 is twice as much as 4, and the relationship between 6 and 12 is that 12 is twice as 6. Therefore, these ratios are equally proportional to each other, although the numbers are not the same. Both can be reduced to 1 to 2. When validating proportional equations such as 4 to 8 and 6 to 12, multiply the two outside numbers, the extremes, and the two inside numbers, the means. So 4 times 12 and 6 times 8, because both answers are 48. It is a true proportion. The product of the means will equal the product of the extremes in a true proportion. To verify this equality when written as fractions, cross multiply. So you can essentially check your answers by cross multiplying. If both numbers are not the same, then your answers are wrong. And we will go through many of these examples as we continue through the program. Solving for unknowns using ratio and proportion, that's going to be the basis of all the math we kind of do in the healthcare field. This is the method often used to calculate different quantities of medication or to calculate doses. Knowing 3 of the 4 parts of the proportion is necessary to solve for the 4th. Let's just go ahead and do example 2.31. All right, so we have a proportion in example 2.31. So 5 over 35 is equal to x over 28. And this right here is going to be the majority of what we do for math and pharmacy is proportions. So what we're going to do is first take the x and the number it's diagonal from and rewrite it as 35x. Write that equal sign, bring the equal sign down, and then also rewrite it as 5 times 28. All right. And if you know how to do proportions any other way, if you learned another way, which I actually learned another way, you can do it that way. Whatever way works the best for you. And the other way is the same thing. It's just you don't write everything out like this. So don't think I have a secret way I'm not sharing with you. So first we need to do the 5 times 28, which is 140, and 35x. So now I have 35x equals 140. That crossed into that, or that changed into that. All right, so now I want to get X alone. So to do that, I have to get rid of this 35. So if I divide it by 35, that crosses out and I just have X. But I also need to divide this side by 35. So 140 divided by 35 gives me 4. Now, the greatest thing about proportions is you can plug in your answer and check your answer. So if this is 4 times 35 is 140. 5 times 28, we already know is 140. So they must be equal to each other, and this is, so the answer is correct. Computation of a given percentage of a quantity may be determined in order to ascertain the part of a whole quantity that is in question. If a percent of a whole quantity is in question, the known percent is changed to a decimal form and multiplied by the whole quantity to provide the needed information. So let's go ahead and do example 2.32. Example 2.32, what is 3% of 42? So first thing that we should do when we have a problem like this is take that percentage and turn it into a decimal. And they have those directions right there in the problem. So to change into a decimal, we're gonna divide it by 100. So 3 divided by 100 is 0.03, like they've said. And then we'll just multiply that 0.03 times 42. That's all we do for that one. And we get 1.26. So what is 3% of 42? 1.26. All right, so now we have example 2.33. 15 is 60% of what number? So 60 over 100. So we're turning that 60% into a decimal by placing it over 100 and then dividing. So we have 0.6. So now we're going to have 0.6x equals 15. Now we want to get x alone. So to do that, we have to get rid of the 0.6 by dividing 0.6 divided by 0.6. We have x alone on this side, and now we also have to divide this side by 0.6. And we get that x is equal to 25. So 15 is 60% of what number? 25. And example 2.34, what 15 is what percent of 45? So for this one, we're gonna go and then we want 45x equals 15, and then we want to get rid of the 45, so we have x alone. So if we do 15 divided by 45, so another way to do those problems we just did is to use the ratio and proportion method. So if you look at through these examples, they're just going over all of those using ratio and proportion, which you definitely can do, whatever is more easier for you. Before continuing to another problem, always ask yourself the following question. Does this answer make sense? This is very important in pharmacy math. You will need to use your knowledge of specific medications when asking this question. When an answer is off by only 1 decimal point, the patient would receive either 10 times too much or 10 times too little medication. This is potentially very dangerous. In addition to using your knowledge of drug doses, estimation is a good way to check mathematical calculations. To estimate a number, mentally round it to a slightly larger or smaller number containing fewer numerals. Then perform the calculation mentally, knowing that the mental answer will be slightly higher or lower than the actual calculation, but it'll be close to the desired answer.